All right. Good morning, everyone, and welcome. We are going to attend the first speech of the day, and our speech is named "Build a Data Pipeline Using DBT, Trino, and MinIO." Let's start from a small note about how you can interact with us. So please log in into Slido, put the code GeeCON, and we will be able to see all the questions that would like to ask. There will be our administration that will quote the questions and will show us the most quote. All right, so as short introduction about ourselves, I'm Simon. I'm a senior staff engineer in Grid Dynamics and Big Data Architect. And with me, we have my colleague, Francesco.
Yes, hello everybody. My name is Francesco. I'm a big data engineer at Grid Dynamics. And yeah, I will talk later and I will show you what we prepare for you.
Okay, so we start from the problem. So as a big data architect, I've received several times cases where just someone says, I want Data Analytical Platform. Okay, what should you do? I don't know, can be data mesh, can be a data warehouse, can be data lake. Okay, perfect, where are you going to run it? This phase, I don't know yet. Can be Azure, can be Google Cloud, can be, or maybe I can run it on my data center. Okay, but please pay attention. We have really limited budget. Who never heard of something like that? So here is, after so much research, POCs, tests, we landed in something that is pretty light, open source, and especially for our case, cloud agnostic. So what we landed with is Trino. For who doesn't know, is former Presto. Francesco will talk more about it later. DBT is data build tool, and it will be mainly used for orchestrating and managing the whole platform. And somewhere this data have to be stored. So that's why we have MinIO. MinIO is our main container for all the object stores. All right, so I will pass the mic to Francesco that will kick off.
All right, so let's start with the first component of our pipeline. So let's see what is actually MinIO. MinIO is defined as a high-performance object store. So let's start from the object store part. Object store is a computer. You hear me?
Yeah.
Okay. Object store is a computer data storage. All right. Okay.
Prova così.
Is okay now? Okay. So as I was saying, object store is a computer data storage that manages data as objects, as in the name, as opposed as other storage architectures, like for example file systems, which manage data as file hierarchies, or block storages, which manage data as blocks. So in our case, MinIO is where we ingest all our data. They will be stored there. So that's why it's in our pipeline. And regarding the high performance part, from their documentation, we can read that this is the world's fastest object store. And they, of course, provide a lot of benchmarks and studies about it. But one thing is sure is that, and we tested actually, MinIO is really fast, and it's a really good point for us. So let's see why we choose actually MinIO in our pipeline. Well, first of all, as Simon mentioned before, this is like a hybrid solution. So it works both on the cloud, on-prem. So in fact, MinIO is actually Kubernetes native and provides an APIs compatible with S3. And again, in the documentation, we can read that MinIO is the only object storage which is a suite available for every public, private cloud, Kubernetes distribution, and the edge. Another important point is that MinIO is 100% open source with an actually quite active community. And what else? Well, MinIO, it's actually solving a big problem. You can imagine working with big data, we can receive any type of data. We can receive videos, images, log files, really whatever. And the big advantage of MinIO is that we can store everything there, structured data, unstructured data, and that's also why we choose it. And another problem when it comes to big data is for sure the scalability. You want to deal with different amount of data really fast, and you don't want to spend more than you need. So MinIO is actually designed to be scalable, and that's another good point of why we choose it. Okay, now we're going to talk about a bit the functioning of this object store. So we can say that MinIO, it organizes objects using buckets. Let's go like slow on this and check first of all what is an object. It's a binary data, and sometimes you can find it referred as a blob, which stands for binary large object. And let's say it's a simple self-contained repository that includes the data, the metadata, and a unique ID number. And this information will be needed to retrieve and locate this data. And like I said before, in general, think of an object like really everything, because this is what we will put in MinIO. While for bucket, imagine it like similar to a folder directory, or a directory, in a file system. And so where each bucket can actually hold several objects. And if you're wondering if MinIO supports something like a organized object like in a file system, well, this is actually possible thanks to the prefix method that allow you to prepend a string to every object. And in this way, you will have something like a file system architecture. So another important part of MinIO, which is similar to S3, is that it's supporting versioning. So in case you are gonna like overwrite an object, you're not gonna lose it. You're just gonna have a new object with a new version, and this is saving you in case of accidental deleting or overwrites. So at this point of the presentation, you might have thought, okay, but isn't S3 the same as MinIO? Well, the question is legit, of course, but the short answer, really short and simple answer is no, they're not the same. They are just API compatible. So MinIO as an object store can act as a persistence layer of any S3 application. So there's just a little bit of information more about these two. All right, so now we come at our the core of our pipeline, which is Trino. And about Trino, as Simon mentioned before, you might have heard about Presto or Presto SQL. Well, this is because there was the previous name of Trino. Trino was born in 2012 at Facebook, and the creators, they actually want to keep it open source and community-based. But Facebook didn't agree with them, let's say, so this brought a litigation and eventually a split. And yeah, that's why they had to change the name into Trino. But thanks to the creators, let's say now it's open source, and for us it was a good plus. So, okay, what is Trino? Well, sometimes you can find it as a TrinoDB, but this shouldn't fool you to think that it's a database. Just because you can run some SQL query on it doesn't mean it's a database. In fact, it's a SQL query engine, is defined. And it was great for us because, as we said, we want to have a data source agnostic platform, and you can mount Trino on every data source, which of course is SQL readable. And so for us, it was like a perfect fit. And let's say this reduced the gap between the user and the knowledge related to the underlying system. So you don't have to care about what it's under, you just run on Trino the SQL statement and the queries, and it will work. A very important point is the fact that Trino is distributed and again scalable. I mean, of course, we want scalability at this point of the pipeline. And on this part, it's really great that Trino let you separate the storage part with the computing part. So if you need more computing power for a query, you have separated from the storage, and this really gave us a huge advantage. All right, let's focus now on what made us choose Trino for real. So the first, like we said, again, data source agnostic. So we can really use it everywhere. And why? It's thanks to the connectors. Connectors in Trino adapts actually the Trino platform to a data source. And let's think about a connector like a bridge between Trino, query engine, and the data source. So, and this is actually set at the catalog level. So every catalog is associated with a specific connector. And if you examine a catalog configuration file, and you will see later, you will see that there is a mandatory property, which is connector.name. So that's how it understands Trino, the connectors to the data source. So apart from that, we will see later more what is a catalog. But important part is that Trino is already providing some built-in connectors, like JMX, for example. But thanks to the community, I would say you can find many others. I'm sure you will find what you need there. You have really Cassandra, Kafka, connectors, Redis, even Google BigQuery, really everything. Thanks to the community, I would say, because many of them were provided by the community. All right. So this is an example of the connector we are using in our pipeline, which is the Iceberg connector. Iceberg in our case is like where we will put all the data after working on them. And it's a format for huge analytic tables. That's all you have to know for this presentation about Iceberg. We use it actually as a data lake. And here you can see at the first line, as I was saying, the connector.name properties, which is mandatory for the catalog. All right, so as I was saying, Trino is distributed, scalable. As you can see from the slide, you can actually scale out and scale in case, of course, you need less. But let's see a bit more how this works. So first of all, in Trino, we have two types of, I would say, servers, nodes, the coordinator and the workers. The coordinator is absolutely mandatory. You must have a coordinator because it's like the brain of our structure, and it's actually taking care of parsing the statements that will pass, planning queries, and managing, of course, the worker nodes. So actually in Trino you can also configure a coordinator to work as a worker. Of course, it's not recommended if you have a big load, but in test purposes, for example, it can be really useful. Okay, regarding the worker, actually is when like the name said, the real work happen. So where the tasks are being processed and executed. And but anyway, remember that it's the coordinator that will provide the results to the client. So the workers are just doing the job, let's say. And okay, let's move on. The second reason of why we choose Trino is actually okay. Let's maybe talk a bit more about the hierarchy of Trino. So there are some concepts that we have to be familiar with to understand later how the query engine is working. So we already covered the catalog and connector part, and inside the catalog, which is connected to the data source as we've seen, we have schemas. Schemas is how the tables are organized. And let's say that the catalog is like representing our database. So inside we have all these kind of structures. We can find, as I said, tables, but also materialized view, or just views. In our case, it's deployed in they're deployed in our Iceberg data lake. Okay, let's now talk about how it's actually working under the hood. So imagine we execute a SQL statement. What will happen is that Trino will turn this statement into queries, first of all. So we are talking about now the coordinator level. After the query is planned, the next step is the distributed query plan. So the query is split into stages, and we are still inside the coordinator. And after this, this is actually when the worker come in, because these stages, they are inside they have tasks, and the tasks are the one who actually run on the worker. And even more, tasks are divided into splits, which make it easier for the and faster actually for the workers to do this job. And okay, I think that's all for now for this part. We can move on and talk about another aspect, a very important aspect of our of our pipeline, which is the security. Because, you know, as we said, we ingest all our data there, and we don't want this to be an easy target from the security perspective. So we can imagine Trino as a user, let's say, which is connecting to MinIO, the same like I would connect to MinIO as a user. And assuming that Trino user needs to be under, of course, the PBAC or RBAC, so the policy-based access or role-based. Let's say that both MinIO and Trino, they cover security into phases, which are the authentication and authorization. Regarding the authentication, let's say, you know, between the user and cluster is one side of the authorization, while the other one is inside the actual platform, so something that happens between the coordinators and the workers. So in the first case, we can use simply, you know, password, username, or LDAP, like easy as this. In the second case, you can actually secure the internal communication between the coordinators and the worker inside the cluster by using a secret management, for example. When it comes to the authorization, MinIO, like we said, we use PBAC and RBAC. So each policy describes actually one or more rules that outline the permission of a user, of a group of users, or a role. And so, because by default, MinIO will deny any access which is not authorized, I would say. All right, so in the next part, we will talk about something that you want to have when you work with this kind of infrastructure, and is the monitoring part. So, of course, Trino support, as I said before, a connector to the JMX, and so you can actually query using SQL, again, using Trino, the metrics of what is going on. And you can query really whatever. For example, the queries failed or success during the last 5 minutes. You know, really any kind of monitoring. And but this is not all, because thanks to the different connectors, you can also, for example, connect Prometheus and Grafana, and then use the monitoring system from there. And another level of monitoring is the UI. Trino, I have to say, has a quite nice UI. This is actually a screenshot from our pipeline. So you see here, you have anyway some information like how many clusters are running at the moment, or how many active workers you have, the memory has been reserved so far. And in the bottom part, we can even say, see actually that you can filter those queries by their status. And you also have nice metrics there, like the speed and so on. So I will leave the word now to Simon again, that will show us something a bit more entertaining.
All right, thank you, Francesco. So basically, what you have just seen is the core that is Trino and MinIO. Why I consider Trino as the core. So DBT, in our case, is what make the whole data ops. But it's Trino that is connected, as Francesco said, to different connectors, to different drivers and to different data sources. So in our case, Trino is our centralized access to all the sources. What DBT does? In our case, DBT manages the overall pipeline from the development, passing through the test until the release in production. What it means? From DBT side, we are able to make all the CI/CD, including testing, including defining the data qualities, including also the communication between the data analyst, the data engineer, and the tester. So you can literally have one single place for 3 categories of teams. So as we can see from the DBT connectors, we have also other one like Azure Synapse, Databricks, Postgres, BigQuery. In our case, it's Trino, but it doesn't mean that you need to use only Trino in this case. We can even have, with DBT, different parts of the pipeline where you can have, for example, the ingestion part that goes from Spark or from PostgreSQL. Can go with the processing one that goes from Trino, and at the end you can make your, for example, data catalog or the views for the client that are, for example, in BigQuery. Okay, so main core about DBT. So the first thing that you will see landing in DBT UI or website is a materialization. So from DBT, you can see from left to right that we have views, tables, incremental tables, merge materializations, and snapshots. The view and the tables are basically create or replace, while incremental take the actual status, make the checks on what is new. You can define different criteria for what is new based on IDs or timestamps, for example, and append the new records. Merge is what most of the time you can hear as insert or update, or most commonly use upsert. And one of the most important feature, especially when you work with data warehouses, that is the snapshot. So how snapshot work is pretty straightforward. Basically, you have one dimension, and that is your table. Usually it's a table that don't grow fast, and it keeps all the history. So you have the record when the validity start, when the validity end, and all the IDs assigned to it. All right, so small parenthesis about data catalog. Why small? Simply because not everyone considered the data catalog in first glance, but it's really important. Imagine that this is the category where the data analyst make most of the effort. Here you can track on what is the meaning of the column, from where it come, and where most probably will flow to. And this is how we land in the data lineage. So how many times when you work with data pipelines, you will see, oh, there is a new table, perfect, but where we have the source data, or what is the purpose of this table? Maybe I can reuse something from there, maybe not. Maybe I need to enrich it with a new data source, or maybe we have to take it from completely different location. That's why also we add Trino for our core. We can imagine the green buttons that are our sources as one, for example, coming from MinIO, and the other one coming from MongoDB. So in this case, you are accessing still to Trino, but for DBT, it doesn't matter. So the query engine is still the same. As Francesco was mentioning, you are using Trino, and you use Trino syntax. What is underlying doesn't matter. So in this case, we created all the lineage in order to connect analytics from, in our case, we use football data. So we collected information about Premier League. And we connected also to weather forecasts. So we could make analytics related to scores, players, and so on. Okay, third category, data quality. How many times you have to go back, get the record at the last valid one, then move forward and say like, oh, damn, maybe I could have checked later, earlier, that column, and now it's null, but it was supposed not to be. So in DBT, you can have two levels of data quality, warning and failure. In failure, you can either store the error and go forward, or you just break the pipeline. So you say like, okay, we have corruption, we stop. So in two cases, you can either have just the warning or the failure provided in your log, so you can connect it to other sources, like for example, Logstash, Elasticsearch, whatever, in order to analyze these errors. Or DBT already provide a location for errors. So you can reuse your data engine, so your data warehouse location, also for storing the failure, and DBT will create a dedicated database. So from time to time, you can go there, check, oh, you have an alert, and so on. All right, here is actually how our platform from the main core standpoint looks like. So as you can see, we have MinIO on the bottom, Hive as our meta store, Iceberg is our data lake, Trino is main core, as I said, and DBT. But how we actually move the data from side to side. So here we can see 3 times the DBT. Why? DBT use an authentication, as Francesco said, that is defined to access specific type of tables or sources. So let's say that we are at the first stage of the pipeline. We have the ingestion as a bronze catalog. So this user access only bronze and move to silver. Same from silver to catalog, silver catalog to gold, and so on. So every user has specific roles and specific policies. As Francesco was saying, defined in both Trino and MinIO. Because you access Trino, yes, but that Trino user needs to be authorized also to go in MinIO and fetch the data. All right. Last but not least is how we made the access. So here we can go over the, oh, here we go. So as we can see, sorry for the black terminal, basically we run DBT pipeline, and we can see how from Trino side we'll be querying. So this is the bronze side, and from the bronze side we have ingested the data. This can be done via all the orchestrator tools, or shell script, or Git actions. You have all the potential way for orchestrating that. And at this phase, we can see that Trino is starting to consume all the requests. So we have like 2 parallel queries. We perform all the activities there, then start the test where you see pass, planning, continuing to perform the pipelines until we have the pipeline that is at the phase where we are already seeing the catalog provisioned, and at this phase we turn the gold. So as we can see, this is done manual from our side just for the sake of the demo, but everything can be automized with first one succeeding, great, go to the next one. In the meantime, there will be our agent that is checking the queries. We go over it. We have other catalog provisioned. And here from Trino, we can see now all the queries that finished. So let's imagine that some of them fail, and we set up DBT to do not fail on error. We can go here and check all the details, metrics, the planned query, the executed query, and all the metadata information about stages, tasks, splits, and so on. This will be really useful, especially during development phase, where you can see actually your query, how much it performs, how many data it consumed, and so on. So here we use the beaver. We have the query of the gold data regarding, for example, how many yellow cards, red cards have been taken depending on the weather. Okay, so here is a representation of our lineage. So we go bronze, silver, you already seen it from the previous one. And here you can navigate and also see specific table details. So here we have all the tables, all the data catalog, how the data is moving from side to side until you arrive at the destination table. And going forward, you can also have gold. So you see that in green, you always have the sources depending from the previous processing. Those are already calculated and they are already available from the catalog standpoint. It doesn't mean that the data is there, but we expect to be there. So here we can see all the detailed query, how is done in DBT. DBT uses Jinja template for performing the creation of the query. It compiles it based on our settings. And most of the time you will see that the data, the query created is really small using Jinja, and then it gets exploded because you can have arrays, you can have if conditions, you can have inclusion and exclusions. And at the end, you can also make the tests. Tests are both SQL, macros, or Python. In this case, you can see this one is a test macro that gets transformed in a query that will check how many records are taken from valid and not. Okay, so that's the end of our presentation. And can I play with this stack on my laptop for free? Yes, absolutely. I wanted to go over. Oh, okay. So, yeah, so everything that we used is 100% available as open source. So you can have everything that it can be spin up using Docker, or especially when it comes to DBT. DBT is just a Python library. So you can just take it as with the classic build tools like pip or Anaconda, and you can play with it. Trino, I would rather suggest to go with Docker because it's you need, as Francesco was saying, at least one coordinator and one worker. MinIO, you can have it both ways. You can install it on your local, you can install it on the cloud, you can put it on Docker as well. So yeah, the short answer is yes. All right, I see that there are no other questions. Thank you everyone for joining the call and to have listened to us. Hope you liked our first speech of the day in our GeeCON, and enjoy the rest of the day.